Hello, this is Michael.
And this is Ryan, and this is our Lab 8 studying lasers.
Here in Part A of Lab 8, we are doing laser cavity alignment, or more specifically, lasing. We first align the laser components using the green laser as a reference. We then reflect the light back into the cavity for gain once our lasers aligned. We can then absorb the various modes that are created with our laser by adjusting the mirror position. Another way we can change the modes of the laser is by adding strain to the mirror cavity. As you can see, we found various modes of our laser, including rectangular symmetric modes and circular symmetric modes. Um, you can see that we had a very fine laser because we did a very good job with our alignment. Here you can see some of the various modes that we found. We found a 0, 3 circular symmetric mode and a highest mode of 0, 6 rectangular symmetric.
So for part B, we're using the Fabry-Perot interferometer, and we aligned our Fabry-Perot interferometer and used our oscilloscope to measure the mode spacing of our helium-neon laser, and we found a mode spacing of 0.613 gigahertz. And we know that our mode spacing is equal to c over 2nl, where c is the speed of light and l is the length of our cavity. So we can measure L and compare the value that we get. We measured L to be around 22.5 centimeters, and that gave us a value of 0.667 gigahertz for our mode spacing.
For part C, we used the optical spectrum analyzer to first align our helium neon laser beam to hit the detector with the two mirrors. We then compared two different lasers, the Heine laser and the laser diode. We saw that the Heine laser had much better mode suppression, as you can see, and had a wavelength around 632.85 nanometers, with one major peak and a couple other small ones. The laser diode, the much smaller and cheaper one, had about a 656 nanometer centered peak, with many modes present and a lot of peaks because of that.
For part D, we're using the same laser as in part B. This time we're using the electrical spectrum analyzer, and we're measuring the cavity length of the laser using its mode spacing, which we found to be 0.889 gigahertz. And using the equivalence to C over 2 NL, we found our cavity length was 16.9 centimeters.